Hello friends. So in the previous session we have just given an introduction to the differentially compound generators, and we drew the equivalent circuit, and so this is the equivalent circuit of the differentially compound generators. You can see the dot polarities, how it is becoming a differentially compound generator. So we wrote this equation, Vt is equal to Ea minus how many drops? 2 drops. Okay, Ia into Ra plus Rsc, and the total flux, okay, will be equal to the flux created by the shunt winding minus the flux created by the series winding minus the armature reaction, because this minus sign is because the differential compounding. Okay, so let us start with the terminal characteristics. So let us close the switch and let us start to load the machine. So loading the machine means what? IL would increase. IL would increase means what? You know that Ia is equal to IL plus ISH. Okay, and IL would increase. That means it is an indication that Ia also will increase. So Ia is going to increase. So let's see the two effects what are going to happen here. So one is that the Ia into Ra plus Rsc is going to increase because of the Ia increase. Okay, which would mean that Vt, which is equal to Ea minus Ia into Ra plus Rsc. If Ia into Ra plus Rsc increases, what happens to Vt? It decreases. Okay, so that is one thing. Let us see the second effect now, which is respect to this thing here. So as Ia increases, you know that this particular value will increase. That means NSC into Ia would increase. Okay, that means this is equal to the MMF of the series winding, that would increase. But look at this equation now. What will happen to Ft now? Because this negative term is increasing, Ft, which is equal to FSH minus FSE minus armature reaction MMF, this is increasing means Ft would drop. This MMF drops, what would happen? The effective flux inside the machine would come down, and if the effective flux comes down, Ea is equal to K phi omega, omega is constant, flux would come down, Ea would come down. And if Ea comes down, what would happen to Vt? Vt is equal to Ea minus Ia into Ra plus Rsc. That means this is coming down, then means Vt will come. That means there are two things which are continuously happening and reducing Vt. In the cumulatively compound generator, remember that there was only one thing which was opposing Vt. That was the Ia Ra drop. The NSC into Ia, the MMF created by the series winding, actually trying to help the machine by increasing its voltage. But here both are against the machine flux. Therefore, the drop in the terminal voltage will be much more severe as compared to a cumulatively compound or a shunt generator. So our comparison is always help with a shunt generator. So if this is Vt, this is the Vt at no load condition, and let this be your IL. So if this is the graph of a shunt generator, okay, so this is the terminal characteristics of a shunt generator, which had only the Ia Ra drop and the armature reaction. That was the only two things which was opposing it. Here you are having armature reaction, the series winding, you can see armature reaction, series winding, and the Ia Ra. Everything is opposing the machine, alright? That means here the characteristic will be much more steeper as compared to the shunt generator. So the voltage will fall off drastically in case of a differentially compound generator. So here it is the differentially compound generator. So you must always take the shunt generator as reference, then only you will be able to appreciate the differential compound generator characteristics. Alright, so with this I will conclude a very small session, I know that, but that is the format of these lectures, right? You first have the introduction, then you have the terminal characteristics, and then you are having the analysis. So I will like to continue with the same trend what we are being following till now. So if you have any doubts, please put them in the comments below. If you have liked this video, please like, share and subscribe the channel, and I'll see you in my next video. Thank you.